Our next speaker then is going to be Leon Flexman, Senior Director, UK Corporate Affairs for X Energy. So, Leon, there you are. Welcome, Leon.
Thank you. Thanks very much. And I just want to start by saying that was a fantastic discussion. Hopefully the results of that will be shared with everybody, that we can, will that be possible, do you know? Brilliant. No, that was really really interesting discussion. And thanks to MTC for inviting me to speak today. I studied briefly in Coventry, and we at X Energy, we've worked with MTC, but I've never been here before. And it's a fantastic facility and a really good event that you've laid on. So thank you very much for inviting me to be a part of it. So I look after corporate affairs at X Energy in the UK, and I'm just going to give you a bit of an overview as to what X Energy is doing globally and then in the UK, and look ahead to what might be happening next. So title of the presentation, Deploying Advanced Nuclear Modular Reactors at Scale, and that is the key point. So just a quick introduction to who is X Energy. Just before I go onto the slide, the deep background is that X Energy was founded by a billionaire who made his money in the space sector and then wanted to put something back into society. And he went to Africa to build a school in a rural community and found you couldn't do it because there was no electricity. And not only was there no school possible, there was no thriving businesses, hospital, communities, etc. So he took a couple of his engineers out of the space industry and said, go away for a year and find a solution to this problem. I don't care what it is, let's just call it X. It can be anything, as long as it makes money. It's not going to be a philanthropic thing solely, and it needs to be clean as well, because he's a passionate believer back then in climate change, global warming, etc. So they went down a few blind alleys, but eventually came across a team of people working on the Pebble Bed Modular Reactor program in South Africa that some of you may be aware of, that had been shut down for political and financial reasons. And to cut a long story short, he scooped up the expertise there, transplanted them to America, and put several million dollars of his own money into developing what had a technology that's been around for many years, but needed some committed investment to bring it to market. So as of now, X Energy was formed in 2009. We're headquartered in Maryland, just outside Washington, D.C. There's around 1,000 people in the company. We have an office here in Manchester in the UK, and also offices in Canada. And it's a Generation 4 advanced modular reactor, a high-temperature gas reactor that we are developing and bringing to market, along with the fuel that will power it, the TRISO X fuel. And the XE100 high-temperature gas reactor, unlike the Rolls-Royce reactor, it's 80 megawatts, but it comes in blocks of 4 units. So 4 80-megawatt reactors that are capable of producing steam as well as electricity. So each of those can do 200 megawatts thermal of steam. And that steam is at a temperature of 565 degrees centigrade, so effectively a couple of hundred degrees more hotter than in light water reactors, with more applications as a result in terms of industrial use. You can also see in the pictures there a simulator and operator training facility and a technical testing facility that we have in Maryland that has a helium test facility in it, alongside some graphite testing as well. So that's a little bit about the company. I mentioned the fuel. So this is it. I have a TRISO X fuel pebble here with me that was manufactured in our pilot plant in Oak Ridge in Tennessee. This one doesn't have any uranium in it. It's a blank, so you needn't sort of back away. And by all means, afterwards, before I have to run away, if people want to come and see what this is, what it feels like in your hand, please do. But it's at the heart of our offer, really, because it is effectively a containment vessel in itself. It has several thousand microscopic kernels of uranium inside it that are triple encased in graphite and ceramic materials that effectively trap the fission products inside. It's designed effectively not to melt under any temperature you would see, to thousands of degrees, even in an accident scenario. And also, due to the density and the makeup of the fuel, it effectively cools by itself in an emergency scenario, so it doesn't need operator intervention or all of the complex systems and barriers that you would have in traditional nuclear. So that obviously has a number of safety benefits and smaller emergency planning zones, etc. But it also means that you have considerably fewer systems, components, structures, etc., of traditional containment that you need in traditional nuclear. In terms of the reactor itself, this is a XE100 80 megawatt reactor with the associated steam generator. And in the interest of time, I won't repeat what's been said already by Brian and also by Rolls-Royce about the standardization, but very much what is true for SMRs is true for advanced reactors as well. Standardized design, one design 1,000 times is our dream. And it is modular both in terms of factory built, road shippable to site, but also modular because we have the 80 megawatts unit. You can use different modules for different applications within the same plant. And I'll come on to that in a moment. And the intrinsic safety features I've mentioned already. One other thing I'd say, just before moving on from this slide, is it does have online refueling as well. So the pebbles effectively are fed through by gravity through the reactor, and then drop out of the bottom, a scan for burn-up rate, and then those that are finished will be taken away for storage and eventual disposal. Those that aren't go back automatically into the top and go through again. They pass through around 6 times over a period of a couple of years. So that reduces, obviously, outage times. In terms of applications, conventional power generation, yes, but also with that high temperature steam can be used to replace process steam generated by fossil fuels currently in existing industries, or for use in manufacturing hydrogen, synthetic aviation fuel, etc. And then also the huge change in the last couple of years has been the growth in demand from data centers, which has been obviously really energizing for the SMR and AMR community. I'll come on to that in a moment. So traditional applications by all means, and we can also load follow. We can ramp up from 40% to 100% of output in 12 minutes. So a number of applications. And then I mentioned that we do fuel fabrication as well as the reactor. So turning from the sort of theory of the technology, let's have a look at progress that we're making in those two areas. So will this video play? Yeah, so this is actually our first of our commercial fuel fabrication plants that we're building in Oak Ridge in Tennessee with enough fuel to power 11 of our reactors. It's licensed, it's in vertical construction, should be operational in 2028. We've had a pilot plant going since 2016 to effectively test and qualify the fuel. And this will be the first of 2 facilities. The next one will be 4 times the size and produce enough fuel for 44 reactors. It will be alongside that. And then we're looking at where we would put TX3 and TX4 and basically scaling up the fuel manufacturing capability as to meet expected demand. Those are the first advanced fuel manufacturing capabilities ever licensed in the US, and the first fuel license for 50 years, fuel factories. And then in terms of turning to the reactors, we have projects already underway in the United States. So our equivalent, I guess, to the Rolls-Royce SMR is the first project that we have underway in Texas on the Gulf Coast. And it was backed by the US government to the tune of over $1 billion of investment through their Advanced Reactor Demonstration Program. Ourselves and TerraPower, the Bill Gates funded advanced reactor, are the 2 projects that the US government is backing. And that's not just been for the first plant, it's been to help finalize the design and co-fund that first smaller fuel fabrication facility as well. So that's our first of a kind. And what it will do is it's 4 reactors on the fence line of an enormous 4,000 acre Dow chemical ethylene manufacturing plant near Houston on the Gulf Coast. And they will be taking 2 reactors worth of a combination of steam and electricity to replace their existing combined heat and power capability. And then the other 2 reactors will be putting electricity directly into the Texas grid, but are available effectively as redundancy, as backup, because like data centers, the chemical plant, it produces so many units it can't afford downtime. So it has that kind of reliability, but not needing to effectively fund and guarantee the offtake of all 4 reactors at once. So that's the kind of benefit of the modularity and the flexible applications of this advanced technology. And the success of that project has led on to effectively interest from the commercial sector. And the big sort of game changer, I guess, for X-Energy was in 2024 when Amazon came on board saying, yes, we like the look of this and we want a pipeline of XE100 projects up to 5 gigawatts across the United States to support the demand that we see coming from our data centers to power our hyperscaler activity. And I think it's probably worth pointing out that there's a lot of announcements about the tech sector coming in and saying, yes, we want power purchase agreements with nuclear. But in our case, Amazon also invested in X-Energy. They have seats on our board. They're not a majority, but a significant investor in X-Energy. And they're putting risk capital into the first project, which is in Washington State in the northwest of the USA, and that is our second project up to 12 reactors in partnership with the existing utility there, Energy Northwest. So these are projects that are up and running, expected to be operating in the early 2030s. And that takes me to, how am I doing time-wise? That takes me to the UK. And I think as a result of this momentum and the commercialization of our technology moving from just being a good idea to projects in delivery, we secured a partnership which is extremely significant for us with Centrica, who is increasingly the kind of significant investor in UK nuclear with investments in Sizewell C, the existing plant, and now coming on board with us to partner to deliver up to around 6 gigawatts of XE100 projects across the UK. And that's critical. We were talking earlier about Brian was talking about the benefits of a fleet rollout. We're not in this to do one project. We're in this to do a fleet of XE100s, and we're looking actively at, I'll come on to the first project in a moment, but we're looking actively at other sites around the UK. And we're starting by looking at a project in Hartlepool. So the plan is for our 4 packs of our reactors adjacent to the existing AGR operated by EDF, so enough power for over 1 million homes, and this will be our 3rd project. So this is not a first of a kind, but it is a first in country, which brings some risks, but a lot of the genuine first of a kind risks will be retired, we hope. So Hartlepool is a great place for this because there's an existing potential heat demand, there is a grid connection, and there is all that capability and expertise and understanding from the existing nuclear power plant and the supply chain. And by a quirk of fate, ours is a gas graphite reactor, and so is the AGR fleet. The rest of you all know the rest of the world went down a different pathway. We stuck with gas-cooled graphite reactors. Now ours is helium-cooled rather than carbon dioxide, but nonetheless a lot of synergies and learning and expertise that we can capitalise on. People probably don't realise, but the United Kingdom has more expertise in high-temperature gas reactors than the whole rest of the world put together. But it's not going to last very long if we don't have the baton handed on, and we're there to kind of take that forward. Is the plan. So with this, we'll create thousands of jobs in construction, hundreds of high-quality jobs in operation, and we hope will be the flagship to lead on to future XE100s across the UK. So we have actually done a fair amount of analysis to look at the fit for our technology into the UK. We did under the co-funded by government, the Future Nuclear Enabling Fund. We looked at how our design could translate to the UK with minimum changes and applicability codes and standards, etc. We looked at the construction feasibility and how we could map that across from what was the approach we're taking in the US to the UK. Spent fuel management as well, working with Nuclear Waste Services and others. And then looking at manufacturing and the supply chain. I should say, actually, we will partner with Cavendish Nuclear on this, who did a fantastic job for us. And the key findings from the supply chain assessment were that a lot of capability exists here in the UK, both in terms of the conventional island, where our design is for off-the-shelf components which can be replicated, but also in the nuclear island itself as well, with that expertise I was talking about, whether it's gas circulation, graphite, etc. But what there isn't is enough capacity for our ambitions. And for us, we looked at 24 critical systems and components and looked at whether there were at least 2 suppliers for each of those. And we concluded that we have enough to work on here, but investment is needed, and industrial strategy being a part of that. Hence, the conversation earlier was very welcome, and the consultation that's coming up, very welcome also. So, in terms of our supply chain strategy,
sorry, Leon, can you give your concluding remarks? We've got like maybe a minute.
Yes.
left.
Okay.
Apologies.
Let me move. Sorry, that's probably the bit you want to know most about, actually. So we're not quite ready yet to formally engage, and I'm very keenly aware of the desire to see procurement packages, confirmed volumes, etc. We are effectively where we are at the moment is going through the advanced nuclear framework assessment process that Brian spoke about earlier. We're being assessed by government and by Great British Energy Nuclear, with a view to getting those elements of government support in place that will help us to unlock the private investment that is going to fund our programme in the UK, with some of that government demonstrating skin in the game for the first project. We will then be reaching out through structural engagement to the supply chain to build on the early work that we're doing with some of the long lead items and some of the early development work, and the studies we've done with Cavendish previously. So watch this space, get in touch via that email you can see on there, or if I've got to run straight after this, unfortunately, but please contact me on LinkedIn if you want to kind of register your interest in working with X Energy, and we will come back and make sure that nobody's missing out as opportunities become available. I won't linger on the last slide. It is really just to say that we're in the mobilization phase at the moment. Next year, we'll be launching a new company as a joint venture with Centrica to deliver the Hartlepool project and potentially the further projects that roll out after that. And we're looking at reaching commercial operation in the mid-2030s. So sorry I spoke very quickly, but I want to make way for the next speaker. And thank you very much for listening. Cheers.